Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations. And today the topic is going to be this critical question of the measurement of emissions, and specifically methane measurement. The oil and gas industry's product frequently includes a methane vapor thread that is either rogue, in other words, it's being emitted unintentionally, or it is intentionally being emitted, but it's intentionally meant to be a small emission. It's all within the standards and regulations that have been approved by various regulators. But the industry does have to measure these things carefully to make sure that they are not in violation of the standard. And this is proving to be a particularly tricky difficulty for the industry, but new technology is coming to the rescue. And today I'm joined by Robert Ward of Kuva, who is going to walk us through a little bit of the storyline of methane emissions and measurement, and how technology is helping to improve the situation. So, Robert, welcome to Energy Innovations.
Hey, thanks, Jeffrey. Appreciate you having me on today.
Now, let's kind of unpack this a little bit about the backstory about methane in particular. Why is methane specifically viewed as a more egregious problem for the environment than, say, other greenhouse gas emissions?
Yeah, so great question. It wasn't that long ago that CO2 was the thing everyone was chasing, but methane has been determined to be as much as, depending on if you're looking at 25, 50, or 100 years, being up to 84 times the intensity. It doesn't have the life that CO2 does as far as being persistent in the environment, but the life that it does have is far more effective, negative effects.
And just for clarity, how long has the industry been mindful of methane's effects? Has this been relatively not new, in other words, new regulations, or has the industry been tracking and worrying about this problem for some time?
I think it depends on which part of the industry, upstream, midstream, or downstream. I think downstream's been more conscious of it. In the upstream side of things, I guess, I'm not sure I know an actual date, but it's kind of been on the top of my head for the last couple of years anyway, and our customers.
Yeah, it is a critical challenge. And traditionally, how would industry go about doing a measurement of the methanes that may be emitted at a specific site?
Yeah, so the traditional method would be to send a crew out or a person out with an handheld OGI, so optical gas imaging camera. So that would be, just a little portable camera, looks like a video camera, and it's able to see those gases in the air, and just as of late, able to do quantifications as well. Prior to that, they would have the visibility to do it, and then they would use a sampler to be able to take effect that would draw that gas off so that they could determine rate of it. The thing that gets really difficult is that the majority of these missions are not always there. They're very episodic or intermittent, and are typically a result of something that's going on with the process that's not normal. And the likelihood of that person being on site when that takes place gets pretty slim. Yeah,
so it's, if you happen to be there at precisely the right moment, it's like witnessing a car accident. There's lots of accidents, but if there's no witnesses, it's hard to know what's really going on.
Well, exactly. It's kind of like something's going on with your automobile, and you take it, but it doesn't happen all the time. The weather's got to be, the temperature needs to be doing this. You need to be at this speed, and you take it into the shop for them to find it. You might have to make a couple of trips before you can find it, right?
Yeah, very true. I have in my own car, I have exactly that issue. The radio doesn't quite work on Bluetooth, but only sometimes, and it's intermittent, and it cuts out and then it comes back. And I take it to the dealership, and they're like, "Sorry, dude, we no idea what it is." Now, I know if I think about a remote facility, there have to be some conditions that make measurement particularly challenging. How about the weather, for instance? What role does the weather play in getting a good read on what emissions might be taking place at a facility?
That's a really good question, and it is impactful. So we've done a fair bit of testing to be able to determine what our sensitivities of measurement are at different distances. And the one variable that's always there that we're building data sets on so that we can account for is wind speed and wind direction as well. So there is a correlation in the natural gas or methane dispersion models that are used that account for wind, but up to some speed, and I think it's around 10 meters a second or about 22 miles an hour, it gets very difficult and pretty much immeasurable beyond that point.
And what about nighttime and inclement weather, such as fog, rain, and snow? How does this hamper or make it either impossible or very difficult to get good measurement, both the traditional method as well as with the challenges for modern technology?
Yeah, so it really depends on the technology method as to how it's going to be impacted. For example, our technology currently uses ambient illumination during the day, and then we're working on a nighttime version which has artificial illumination from within the camera so that we can measure gas around the clock. With regard to inclement weather, things that you get into there is very little impact unless you end up with things like blowing sand or dirt, a dust storm, that sort of thing. But at that point, the wind is high enough that you're not going to be able to measure it anyway. The dispersion models just don't work in that realm. Rain, sleet, and that sort of thing, it's got to be really bad. So basically, if you can see from the camera location to where the leak source is, there's a really good chance that the camera is going to see it as well.
Now, the human eye can't see the vapor like this because it has no.
That's correct. You can see it kind of waving in the air, but you can't actually resolve the volume or geometry of it.
Yeah, a bit like heat waves coming off the cement or the pavement in a hot summer day. You can kind of see the waves. It's distorting the light as the heat moves its way through. So similar phenomenon.
Yeah.
But
it is. It's colorless. It's colorless and it's odorless as well.
So is the camera and the sensor in the camera working with the visible light spectrum, or is it looking for beyond the visible light in some other infrared?
Yeah, so it's actually below the visible spectrum. So it's a shortwave infrared. So we actually, if you think about it, you have a light source, whether it's a reflective source or a direct source going through the methane.
Yeah.
There's a spectrum of light that gets blocked, almost like a diode. And a spectrum of light that gets blocked, and we actually colorize the lack of that particular wavelength that methane and the adjacent VOCs, C1 through C6, that they block.
So on your dashboard or your visualization of this for the human eye, you've made the invisible visible. And you can
exactly.
And does it show as a flow or as a discrete measure? Because you can imagine if you've got a camera, it's almost like watching a movie. You can actually see it sort of bubbling away. What does the technology provide you?
So we generate images that look very similar to this.
Yeah.
So the gas is actually colorized, and the different colors there represent the columnar density. So how much gas is in that particular pixel. So we have two dimensions that you can see, X and Y, but then that colorization is a third dimension. So it takes us near a minute and we generate an image, and then we stack those images, and we're applying some neat new algorithms on top of that. And we're able to extrapolate the volume from one image to the next for quantification.
The amount of data we're talking about here must be extraordinary when you think about it, because of the number of cameras, the frequency of the measurement, the amount of data to go in at the pixel level. What is so there must be some sort of data construct in behind this that you're also working around or working towards. Can you open that up a bit and just share what that looks like?
Yeah, just a little bit. So we do generate those images. We're not taking video, we're creating still images. And those still images are analyzed inside the camera. So inside the camera here is a multi-core edge computer where we do kind of first level analysis. Then we take those candidate images and send them to the cloud.
So how does if you need to provide a sort of a clever update, improve your algorithm? How are you doing that if you're out at some sort of remote site with this edge device? Are you on a communications network? Is that how that has to work?
Yeah, so we have a variety of modems that can be integrated into the unit. So depending on if they're Telus, Bell, Rogers, AT&T, Verizon, or even private LTE networks. So there are a number of operators that have private LTE networks as well. If none of those are available, but the operator has Ethernet or internet access, we can plug into their network as well.
And so, just why would an operator invest this kind of, aside from the regulatory side, and get the measurement? Why would an operator invest in this? Where's the business rationale for an operator? Because at the end of the day, you measure if you're emitting and you're not supposed to be emitting. You want to get your arms around where you've got so you're in violation of the rules. But is there some other dimension here that creates an economic incentive for an operator to get their arms around this?
Yeah, Jeff. So there's the economic component, and there's really a couple of pieces, and some of it are external to how we're used to making decisions. The investment community is really keen these days on investing or making sure that they're investing in operators that are responsibly sourcing gas. So if you think about the methane intensity or indexes that are out there, as people approach 2030, 2050, and their net zero goals, they really need some way to be able to provide evidence that they're on the path for that. So A, that they actually have a plan. B, they're instituting that plan. C, they're backing up that they're using a technology that is providing a tremendous amount of evidence that they're on the right track.
Now, there's been a steady stream of reports. It's not every day, but every few weeks, there's a report that comes out from some reputable science establishment or research institute that says we are under measuring our methane emissions, and usually by some distressingly large amount. So this feels like a chronic challenge for the industry. Surely there must be some operators who are taking this more seriously than others. Would that be a fair characterization? Therefore, we have a kind of a bifurcation of the operator community, some being quite sophisticated and concerned, and others taking probably a much more lackadaisical response to this challenge.
Yeah, that's a really good point. So we kind of see two different tiers. Maybe there's a whole spectrum in there, but there's a minimum responsible operator and then the maximum responsible operator. And are they measuring? Are they doing as little as they can to mitigate fines, or are they doing as much as they can to make themselves attractive, to make their product attractive because it's being responsibly sourced, and also to make themselves attractive to the investment community? A lot of those factors, that 70%, like we heard last week, that these numbers are being reported up by as much as 70%, those are using some basic factors that I believe were established by the EPA. So it lists pretty much every piece of equipment that you can imagine on a production site. And then the operator can go in and quantify all of those devices, and then their operating conditions, pressures, flow rates, and such, and they'll get a factor. And that emission factor is a cumulative number, and then that number is what is being presumed to be so far underreported. And the reason is that those numbers are put out by the equipment manufacturers at the point that equipment is new. So when it's in perfect working condition a lot of times.
Yeah.
So that's part of it. Then as the equipment erodes, you get sand in the gas and filtration and all those sort of things. You have mechanical inefficiencies that come into play. Those are a part of it. And then there's the operational conditions. So if you have an overpressure, you violate a thief hatch, or a thief hatch, the springs go weak on it and it begins emitting at a lower pressure than it should be. Those are the kind of things that happen over time. And that's kind of where that 70% error comes from. It's not a conscious underreporting. It's not done in poor favor by people. It's just something that's happening because of the technique that's being used.
Yeah, when you think about it, you're going from brand new and engineering specification. This is what it should do off the assembly line or the manufacturing line. Put it out in the field for 2 years. Let Mother Nature take her best shot at it, and sure enough, it's going to start to degrade. And the handheld once in a while measurement just doesn't cut it any longer. And we're now starting to see this quite sizable gap consistently appear in the measurement.
Exactly. So last week at CERAWeek in Houston, there was a statement made that I thought was pretty interesting, and it said for us to be able to address the issue at hand, we need to move from mathematics to monitoring.
That's a very interesting statement and a very interesting way to frame it. From the original math, the engineering spreadsheet, this is what it should be, to now, okay, you need to monitor it. Is there a resistance to this in the industry? I mean, it's costly because you have to invest now in continuous monitoring. But at the same time, the industry is constantly having to go out to facilities anyway to do inspections and repairs. So where's the resistance to kind of embracing this? Has it just been there hasn't been a technology that will do this, or is there something else going on here?
So part of it has been that, there is some expense to that, but most of that expense will be recovered, and that quantification, I mean, that's an absolute it's measurable. The other thing is that some of the new EPA rules are not quite out yet. So in November, there were some things that came out as a proposal and then accepted comments back for recommendations on the proposal. And those will be renewed and released in the June timeframe. So a lot of it is kind of wondering what's EPA going to do, or what's the Canadian regulatory bodies going to do with regard to equivalency using continuous monitoring to today's manual processes. But we're seeing quite a bit of momentum already with anticipation of what comes in June.
Yeah, sort of drive and get ahead of the bus here when you think about it. And
absolutely.
Are the rules, you mentioned already Canada and the United States, how do the rules play out internationally? For example, the EU often sets the high bar for the regulation of industry in general. Are their rules higher than those, say, in North America?
Jeffrey, I'm really focused on the North American market right now. And Stefan Bokamp, our CEO, he would be good to address that international component, but we're running so hard and fast right now. We just hadn't kept an eye on that.
Get ahead of North America. Well, the U.S. is, on a domestic front, U.S. is an enormous producer of hydrocarbons. Obviously, one of the top 2 or 3 in the world. So there's ample challenges in North America. Plus, the infrastructure is quite old, and as you point out, the older the equipment, the greater the gap between the original engineering specification and the actual on the ground as measured. So there's plenty of room to maneuver here. Is this a terrestrial problem exclusively, or does it also impact the offshore? For instance, you also mentioned midstream is another place where there's like how extensive and how broad is the gap between the math and the measurement? I mean, it sounds like it's bigger than just upstream.
Yeah, it is. So midstream probably has fewer points. So I think there's in the neighborhood of 7,000 compressor stations in North America. And that's a number I ran across. I don't know if it's accurate or not, but it seems about right. But of those points, when you consider that versus, nearing 1 million production wellheads that are out there and operable, there's the number of leak points is far different. The thing is that in the midstream side of things, the volumes are quite higher.
Have you found, just in the upstream with those millions of wells, have you found specific elements of the infrastructure that are, quote, leakier than others? Like, where is there like a rule of thumb that you could point to, say to an operator, hey, heads up, if you are, you're operating this kind of infrastructure, you probably have some leaks you don't know about.
Yeah, in those conditions are where you have pretty rich condensates or NGLs being produced,
Yep.
and then also oils with crude oil with high degree of associated gas. So we see a lot of that in particular part of the Permian Basin, the Scoop and Stack in Oklahoma, which is very similar to one of the portions of the Eagle Ford Shale and the Bakken as well.
So, digging into that, that sounds like the wetter the resource, the more potential for that product, that the hydrocarbon flow, to foul the mechanicals and therefore create the potential gap versus just a straight dry gas with literally no contaminant in it.
There's you can't say that exactly.
Okay.
And the reason is that if you think about up in Appalachia and Marcellus and even in the Haynesville Shale, where there's a fair bit of dry gas, that's some of the, if you look at some of the satellite data of the flyover and the emissions, those are two super high regions. But that's not necessarily for the same reason that you'd find in the Permian. In the Permian, it's generally because of the tanks that are there. Tanks and compressors are such high violators. In those other areas where they're running dry gas, they might, or somewhat drier, they would operate their wells using plunger lift, which is an artificial lift technique. And some of those legacy wells, they're still running what's called a B valve on them, and that vents to atmosphere to be able to ease the lift on the well. And so those are some big violators, and those are going to have to be addressed. But they're similar in nature, but they're operated completely different.
Yeah, I think that the takeaway for anyone listening to this or watching this is that there is not one size fits all. This is going to be specific by basin, by type of hydrocarbon, by facility, by age. So the fast answer we've relied on to date, just rely on the original math and the design, is now going to have to give way to measurement. Yeah. Now you mentioned chemical facilities, and what about chemical tanks? Not just because if you can measure using this camera technology, you can measure beyond the visible light spectrum. Are there other vapors that industry should be concerned about that they might want to think about measurement? And here I'm thinking about, because there's a lot of chemicals used in oil and gas to keep well bores clean and operational, for instance.
Yeah, we don't have any focus on that. And I think my limited exposure to those type of chemicals that are used for injection for multiple purposes is that the density and viscosity of those products are not really subject to gassing so much. So I don't think
more spill actually.
A spill would be a different deal. We're really focused on the gas component that's getting into the air.
Yeah, exactly. Now, have you stretched beyond oil and gas into other industries? Because emissions, for instance, at abattoirs, landfills, all kinds of places throw off a lot of methane.
We have a lot of inbound interest in those type of applications, and we're really focusing on the upstream and midstream market right now. So we're trying as hard as we can to keep that focus, but there's a lot of motivation to stick a couple of cameras in some of those other markets, just so that they can have a baseline of what the impact could be if they were to scale. So yeah, we are having discussions in those other markets.
Yeah. Let's wrap up this with, if you can share a little bit about the economic effect or the business case when companies put this technology on, aside from they can detect the emission and deal with it. What is the economic value that companies may be reporting to you beyond that simple mechanical fix that they'll put on? How are they measuring the effect of this kind of innovation economically?
That's kind of interesting. Like, how do you put it on paper?
Yeah.
The ROI,
Yeah.
and this is one of the most difficult spaces to be able to determine that ROI, because the ROI could come in the form of you're saving more product, it's going to air, not going to the environment, so that you're measuring it right, so you can sell it. The other part of it is that it goes towards your methane intensity index, or whatever your corporate goals are for your 2030 and 2050 net zero initiative. I'm just trying to think of some of the other things that one of the things about continuous monitoring is you can eliminate a lot of drive time with the SCADA systems that people have deployed, especially in the last 15 or 20 years. Is they're starting to they went from operating by exception to operating by priority, so that now they're only taking care of things that is going to create value or is going to prevent or mitigate downtime or an outage. So there's I think it's really not having to run around and check a lot of these things is giving people more time to do things that can be more impactful and optimization of the rest of the process. Other things are media. So it's really hard to measure the impact on shareholder value when an operator makes a press announcement and says, hey, we're deploying this technology at this rate on these particular sites so that we can achieve these goals and increase value for our shareholders. There's some measurement there that could be put, a pencil could be put to as well. Yeah. We've not seen what that math looks like, but I'm confident that it's there.
Yeah, I would be of the same view. You've touched on a number of things, actually. Drive time, safety, insurance, cost and productivity of resources, because you're not wasting time visiting facilities that don't need to be visited, because that's the usual pattern, just drive a loop and not actually prioritize correctly. So you're fixing that norm in the industry or changing that norm. And there will be absolutely financiers who will say, I will invest in your company because you are taking ESG seriously. It's a kind of a distinctiveness relative to market. So
yeah, for sure.
Yeah.
Not to mention that a single day's fine in Colorado is could pretty much cover the cost of deploying a technology like this on a site.
Yeah, yeah. It's the mathematics is the penalties are go up. There's definitely an angle there. Is there a I mean, aside from the, I know you do collect data from the sensors. How does the data factor into this? Does it play a role in helping to, aside from directing workers to the wells that have the priority, how else could that data be used, or how does it contribute to improving our understanding of equipment and operations?
That's a really good question. So what we're doing is we're taking the data and making that data available for ingestion into the SCADA system. So when we start seeing emissions come from either produced oil tanks, NGLs, or water tanks, and we're seeing emissions from there, we can take those event times, the timestamp and duration of those events, and correlate it with what's happening in that you can see in the SCADA system, so that whether just with the human eye, it can become obvious, or you can run some back-end analytics on it and find out what part of your process control system is causing these emissions to happen. And from there, you can take operational measures, sometimes over the SCADA system without even have to drive to the site. You can make changes. One example of that would be that had a particular customer that had a lot of gas flowing out of their produced water tanks. And simply by extending the retention time or the duration between separator dump cycles, we're able to let a bunch of that in-train gas break out and flow, so that when the separator dumped, there was less going to the environment.
Yeah, that's a great example of value capture that was otherwise not available, and brings this home that there is absolutely an economic case to do this.
Yeah. So another one that's kind of operational that was similar is we had a flow line going from the tanks to the BRU, and could see gas trickling, and was almost thinking maybe it's maybe it's a weird shadow or something. So it was checked out and found that there were pinhole leaks or pinholes all in the bottom of that flow line. So the line didn't have much slope to it. So the liquids were dropping out of the gas and they're super corrosive.
Yeah.
So they ate holes in the pipe. So as the vapors on the tank increased, they were pushing gas out of those pinholes. So we were leaking. Then to the point that the VRU turned on, the pressure got high enough and the vapor recovery unit turned on. Then they started drawing the gas off, but they were also sucking air through all the pinhole leaks. So they were getting kind of double whammied from a process perspective. And it just wouldn't have been caught without the camera on site to see it.
Yeah, the engineering, all the engineering math in the world was not predicting that.
Yeah.
Pinhole leaks in a flow line. Robert, thank you very much for coming on Energy Innovations today to discuss this very fast evolving and now very critically important world of gas measurement.
Thank you, Jeffrey.
So this has been another episode of Energy Innovations, and please tune in again in the very near future for another episode, and I will catch you all much later. Bye for now.
Thanks for joining our latest interview on energy innovations from Energy Now Media. Don't forget to hit that like button, subscribe, and share this video. You can contact us at info@energynow.com to book your appearance or to become a sponsor.